Now we'll be moving on to question number 21. Question number 21, it says that the graph shows the relationship between the forces acting on a compression string and the change in the length of a spring. So there is a force acting and the change in the length in mm is given. One of the springs is placed in each corner of a horizontal square plate. The axis of the spring is in a vertical direction, and the four springs they support a total load of 160 newtons. What is the total elastic energy stored in the four springs? Now, basically, when you put a spring, when you're putting four springs on a horizontal plate together with just a one total weight of 160 newtons, that 160 newton weights it gets divided among all of the four springs. So each of the springs is technically getting 40. And what you're supposed to find is the total elastic energy total in the four springs. So each of the springs it gets a 40 newton force because 160 divided by 4 is 40. Now at 40, what's your extension? At 40, your extension is basically if you go from here and then you see at 40 your extension is basically 2.4 mm, right? 2.4 mm. That is equivalent of 2.4 into 10 raised to negative 3. Wait, 2.4 divided by 1000 is 2.10 is negative 3 in meters. So now what's the formula to find the elastic energy? It's actually half of f of x. Since we need to find for four of them, we'll have to multiply this by 4. So it is technically 4 into the half. The force is 40. The extension is 2.4 into 10 raised to negative 3. So it's 4 into half into 40 into 2.4 into 10 raised to negative 3. That gives you 0.192, which is 0.19. Therefore, the answer for question number 21 is B. I hope this is clear. Question number 22. Which row correctly identifies the properties of all the electromagnetic waves? Now, we know that all of the electromagnetic waves, they are transverse waves and they're not longitudinal waves. So options C and D are a straight cutoff. They can travel in free space as well because the light from the sun reaches us. So therefore, the option is 22A. Easy question. Question number 23. What is the approximate range of wavelengths in free space for infrared radiation? Now, I know that visible light is basically 400 nanometers to 700 nanometers, this option. And because obviously I have radio waves, microwaves, infrared, and then visible light. So infrared is supposed to have a wavelength which is greater than visible light. That means greater than C. So that would obviously be the option would be D. Okay, I hope this is clear as well. Now, most of the time, you just have to learn all of these wavelengths. There's no real specific formula or a trick that I'm aware of which could help you to learn them easily. But if there is, I will definitely share it before the exam. Question number 24. The diagram shows a car traveling at a constant speed in a straight line between a person P and a person Q from point X to point Y. And this is a Doppler's effect question. The car sounds its horn continuously as it travels. The horn emits a sound of constant frequency. Which statements about what person P and Q hear during the motion of the car are correct? Now, as the car moves from this spot to this spot, the person Q he hears a sound of higher frequency due to the Doppler's effect, whereas person P she will hear a sound of lower frequency. So person P hears a sound of increasing frequency. No, person Q hears a sound of increasing frequency. So this is wrong. And person Q hears a sound of decreasing frequency. No, he hears basically a sound of increasing frequency. Person Q always hears a higher sound of higher frequency than P. Yes, that is correct. So obviously the answer can only be 24C, which is the third statement is correct and the other statements are wrong. A progressive wave of 300 Hz is traveling with a speed of 600 meters per second. What is the phase difference between 2 points on the wave that are a distance of 0.5 meters apart? Now, first of all, you will need to find the wavelength. V is equivalent of f lambda. Lambda is V, which is 600 divided by f, that is 300, which is 2. Now, since it's 0.5 meters apart, 0.5 over 2 is basically 1/4. So we'll need to find 1/4 of 360 in order to find the phase difference in angles. That is 90 degrees. The phase difference in angles is the same as the phase difference in wavelengths. So once I find the phase difference in wavelengths, which is 1/4, I can find the same in the angle, which will be 90 degrees. Therefore, the answer for question number 25 is B, 90 degrees. Question number 26. A polarized beam of light with intensity of I is normally incident on the polarizing filter. The transmitted light at intensity I, the filter is rotated about the normal axis through an angle theta, and the translated light has an intensity of 0.75 I. What is the angle theta? Now we know that the final intensity or the transmitted light's intensity is equal to the original intensity into cos squared theta, right? Cos squared theta. So when we get this value, um, for example, we could say that the final intensity 0.75 I is equivalent of the original intensity, which is I into cos square theta. I can be cancelled out, so cos square theta is 0.75. Okay, so the cos theta would be the root of 0.75, and the theta would basically be cos inverse of the root of 0.75. Cos inverse of the root of 0.75. What is that? That is 30 degrees. The formula is I is equivalent of I, the original intensity of just like the final intensity is same as the original intensity multiplied by cos square theta. So the final intensity 0.75 is equal to original intensity into cos square theta. Cancel out the i's. Cos square theta is 0.75. So cos theta would be the root of 0.75. Therefore, you get 30 degrees. 26a. Question number 27. Light waves are emitted from two sources. What is the necessary condition for the observable interfringes to be produced? Now, whenever you want to produce observable fringes, you have to ensure that the waves are coherent. Coherent waves are basically waves that are constant frequency, and if you want the interference fringes or from the double slit interference to produce, they have to be coherent, which is a requirement. The diagram shows a water wave in a shallow tank. The wave is diffracted through a gap in a barrier and spreads. The wavelength of the wave is much smaller than the wavelength than the width of the gap. The wavelength of the wave and the width of the gap have changed by a small amount. What combination of changes will increase the amount of spreading? Now, basically, the maximum amount of spreading is when the wavelength is equal to the gap. Here you see that the wavelength is too small and the gap is too big. So ideally, you should be decreasing the gap and increasing the wavelength to have the best diffraction. You increase the wavelength, so that is option C, and you decrease the width of the gap. So therefore, the correct option would be option C, where you increase the wavelength and decrease the width of the gap so that they'll almost be similar to each other or closer to each other, which will cause the maximum amount of diffraction. Now we'll move on to question number 29. And question number 29, it says that lights of wavelength 567 nanometers is incident normal in a diffraction grating. The grating has 400 lines per millimeter. A number of diffraction maxima are observed on the far side of the grating. What is the angle between the second order maximum and the third order maximum? So you would take the formula, because of the diffraction grating, obviously there's only one formula. D sine theta is equivalent of n lambda. We need to find two of the values of angles and then subtract them to get the difference. Okay, now for the first value of angle, obviously sine theta, I would take the third one and then I'll take the second one. The sine theta, the n value is 2, the 3 into lambda. Now what's lambda? Lambda is 567 nanometers. So 567 into 10 raised to negative 9 nanometers divided by d. Now d is the confusing value. What does d refer to? It refers distances between the two. In this you have 400 lines per millimeter. So ideally the difference between one of them, like the distance between one of them would be 1 over 400. But since this is in millimeters, you got to divide this by 1000 to get this in meters and put this entire thing in brackets. Now this is sine theta, so you can obviously do sine inverse theta of this to get the value of the first angle. I'll not write it down, but I just know what I'm doing. Sine inverse of 3 into 567 into 10 raised to negative 9 divided by 1 over 400 divided by 1000. Okay, so that gives me an angle of the first angle when n is 3. The angle is 42.874083 874 Now I can, for the other one, I simply have to change. Okay, sorry for that. I'll have to change the value of n to 2 now. N will be 2 and get the angle. So when I get the other angle, I find that it is equivalent of 26.97489,189. Okay, so now I need to subtract these both. 42.87490837 minus 26.97489,189. That gives me 15.9. So therefore the answer would be C, which is 15.9. 29 answer is C, which is 15.9. 30. Two cylindrical conductors X and Y are made from the same material. The conductors have equal lengths, but Y has a smaller diameter than X, and they're connected in series to the cell. That means the current across both of them is the same. Which row compares the number of average carriers per unit time passing through X and Y, and also compares the drift speed. Okay, now let's understand this. For example, for X and for Y, I'm taking two formulas here. I is equivalent of A N V Q, which is the formula given on the first page, and I is equivalent of A N V Q. I basically refers to the current, A refers to cross-section area, N refers to the number of electrons per unit charge, V refers to the drift velocity, and Q refers to the charge on a single electron. So I know that for both of them, the I value is the same. Okay, so we can say that I is same because they're connected in a series circuit, and all the components in a series circuit, they get the same amount of current. But Y has a smaller diameter, so for Y the area will be smaller, whereas for X the area will be larger. Okay, what about the number of charge carriers per unit time? Now what is number of charge carriers per unit time? Number of charge carriers per unit time, if you think about it, it's actually Q over T, right? That is essentially your current. Your current is the same, so these values, the N values, they will remain the same. Okay, so the N value is also the same, and here also the N value is the same. The Q values, obviously it's just a charge on electron, so it has to be same. I can cancel these out. First of all, the N values will be same, so it can't be A or C, because the number of charge carriers per unit time is essentially current, and the current is the same, so it has to be B or D. Okay, now what you're left with is V. Look, if the current is the same, the area is increasing, so the V must decrease, right, to keep the current same. Whereas here, your current is same, the area is decreasing, so the V must increase. So obviously, the V of Y must be greater than the V of X to keep the balance in the equation. Therefore, the drift velocity of the charge carriers in pi should be greater than X. Therefore, the answer is 30D. I hope this is clear. 31. A copper wire, it has a length of 6.4 meters long and a resistance of 0.92 ohms. The resistivity is given as 1.8 into 10 raised to negative 8 ohms meters. What is the diameter of the wire? Now we know that the resistance is equal to the resistivity into the length over the area. The resistance is given as 0.92 equal to the resistivity, which is 1.8 into 10 raised to negative 8 into the length, which is 6.4, divided by the area. Let's try to find the area now. If you do 1.8 into 10 raised to negative 8 into 6.4 divided by 0.92, the area we actually get as, okay, the area value is 1.252173913 into 10 raised to negative 7. This is the area. So I'll divide this by pi. I'll just tell you the calculation, you perform it. I'll divide this by pi. So dividing by pi will give me 3.985793357 into 10 raised to negative 8. This is the value of r squared because the area is actually pi r squared. So if I square root this, I will get the value of r. The square root of this value is 1.99644,518 into 10 raised to negative 4. Obviously, for diameter, I got to multiply this by 2. So that will give me 3.9928936 into 10 raised to negative 4, which is closest to C, which is 4.0 into 10 raised to negative 4. Therefore, the correct answer is 31C, which is 4.0 into 10 raised to negative 4. Then comes question number 32. A thermistor is connected to the cell with a negligible internal resistance, which graph shows the variation with the temperature of the power dissipated in thermistor. Now, thermostat is a type of variable resistor whose resistance is low at high temperatures and high at low temperatures. So when the resistance is, as the temperature increases, the resistance will decrease, and as the resistance decreases, the current will increase. Since the power is equal to IV, if the current increases, the power will increase. Therefore, as the temperature increases, the power should increase, and the graph would be A. Okay, 33. A metal electrical conductor, it has a resistance of 5.6 k ohms, 5600 ohms. A potential difference of 9 volts is applied across resistance. How many electrons pass a point in a second in 1 minute? In order to find this, we'll need to find the current first. So we know that V is equivalent of IR. In order to find the value of I, it will be the value of V, 9 volts divided by R, which is 5600. That will give me the I value as 1.607 142857 into 10 raised to negative 3. Now once you find the value of I, because Q is actually equivalent of I times t in seconds, I'll need to multiply this time value by 60 to get the charge value. So I get the charge value as 0.09642857143. Now remember, this is the total charge. If I want to find how many electrons passing, I will need to find a charge on a single electron. That is given on your first page. If you go to the second page, you see the elementary charge is 1.60 into 10 raised to negative 19. So you divide your total charge by 1.6 into 10 raised to negative 19. That gives you 6.0267857114 into 10 raised to 17. Right? So for that, the answer would be 6.0 into 10 raised to 17. 33, the answer is C. 34. Which circuit symbol does not represent an electric component that is designed to emit sound waves? The answer would be B, because this is a heater that is not designed to emit sound waves. 34 is B. Okay, now 35. The diagram shows a junction in a circuit with 3 wires PQ are P'd. The current in P and Q is 1 amperes and 3 amperes in the direction shown. How much charge passes a given point in the wire R in a time of 5 seconds? So basically, when you're considering a time of, let's say, 5 seconds, how much charge passes a given point in wire R? So the current that is leaving this junction is 3 amperes, but entering is only 1 ampere. That means at this point 2 amperes would be entering. If you want to find the charge, because Q is again equal to IT, the charge will be 2 amperes into 5, which is 10. So that's our 35 answer would be C. 36. A cell of electromotive force E and an internal resistance R is connected in series with a switch S and an external resistance R. The potential difference between P and Q is V. Which statement is described when S is changed from open to closed? Now, first of all, there's a lot of doubt in the question that what does P and Q refer to? P and Q is actually the terminal potential difference. That is basically when the potential difference passes across here, here, here. At T, the battery basically, or the charge, gains energy from E, and then when it comes down to Q, it again becomes 0 and again gains to P. It will not be 0 because there is resistance R over here. When you keep the circuit open at P, it gains all of the, the value of EMF from E, but does not lose anything. So at P, it would actually be the value of the voltage. It would actually be E. The potential difference between P and Q, when the switch is open, it would be equal to E. Now what happens is that when you close the switch, there is a current in the circuit, and when there is a current in the circuit, the resistance, basically some of the energy is given up on this small resistor because there is a PD across this resistor. So what happens is that the terminal potential difference will decrease because some of the PD goes to this and the remaining PD goes to this point. So the voltage V, which is the potential difference between P and Q, decreases because there is a potential difference across the small resistor R. Okay, I hope this is clear. I'll just clarify it again because this question seemed to somewhat bit confusing. Okay, basically, when you see the points P and Q, it actually refers to that when at point P, all of the EMF is gained, and at point Q, the EMF is returned to 0. We're not considering the internal resistance circuit here. But when the switch is open, it will gain at P, but the current does not flow. So the potential difference when the switch is open is actually equal to E. When you close the switch, what happens is that there is a current in the circuit, so that means there is potential difference across this resistor. So some of the EMF will be used to deal with this internal resistor. So therefore, the potential difference between P and Q, or the terminal potential difference, decreases. So V decreases because there is a PD across R. 36B. 37. What is the general description of a baryon? Now, baryon falls in a category which is called as hadrons. Hadrons, and hadrons consist of baryons and mesons. So basically, baryons have three quark particles which do not need to be the same flavor, but it's not that's a must. They can be of the same flavor, but they do not need to be of the same flavor. So that's why 37 is B. 38. A stationary nucleus has a nucleon number of A. The nucleus decays by emitting an alpha particle with a speed v to form a new nucleus with a speed of u. The new nucleus and the proton move away from one another in opposite directions. Which equation gives v in terms of a and u? Now this is basically a question of conservation of momentum. So what they're saying is that initially it was 0. The final momentum should also be 0. A proton has a mass of 1 and it has a velocity of v. That should be equal, like the minus, because the other one is moving in the other direction. Now what will be the mass of that? Initially your total mass was a, but proton took away one mass, so ideally the mass is a minus 1 into the speed of u. So I can move this negative to the positive side, so a minus 1 into u is equivalent of v into 1, which is basically v. So I can say that my option B exactly matches this, and therefore this would be my correct answer. Conservation of momentum. Okay. Now, what is the change to the quark composition that takes place during a beta plus decay? During a beta plus decay, a proton changes to a neutron plus an electron, a positron and a neutrino. A positron, neutrino, sorry for the spelling, neutrino. This is a positron. So how does a proton change to a neutron? Basically, an up quark changes to a down quark. 39D. Last question. What is the charge of on a charm quark? A charm quark, basically it has a charge of 2 by 3, similar to that of a top and a up quark. And with this, we have came to the end of this paper. I hope this video was really helpful to you, and I hope I've cleared any doubts that you have through the whole paper. If you have any further doubts, please post on the comments below and I'll try to respond as soon as possible. Wish you all best of luck for your upcoming exams, especially your MCQ exams, before your well-deserved and relaxing summer break comes into play. Till then, take care, and if you have any new video suggestions, please do put them down below. I'll try to make a video on them. Don't forget to like, share, subscribe, and bye.